Okay, there we go. Guys, we're running. We're live. Shh.
Alright, so this is our centrifugal fan plate by
Luke and Alex.
Alright,
so for our first thing was the first thing we went about for it was kind of the whole motor component, because we wanted to go with a centrifugal fan. So the challenging, there were like a lot of challenges to go with it because it's not as efficient as like a regular fan blade or anything else. So basically how this works is it's kind of like almost way in like a cylinder funnel in a way, and the air intake comes through here, it sucks it up through, and then as it goes around it exits here. So this was one of the models we ended up printing with the motor mount on the side.
Okay, so we went through a lot of process to make these wings. We kind of messed up once, so we got an extra wing. But, we started with templates. We had to remake these a couple times because Sammy kept making them not the right size and having holes in the top, so we'd have to put tape over it and stuff like that. And we finally got it to a point where we really liked it, and we put it on, and it didn't quite come out of the foam, so our wings kind of got a flat top of it a little bit. That's okay. We have to make it with a pretty good amount of camber underneath because the centrifugal fan is going to be so heavy. The wings would have to be pretty big and cambered to create enough lift to help it stay in the air as best as possible. So it has to kind of be like a glider in that aspect. We originally made this thicker. I made it. I thought it was pretty great. And Luke was like, no, I don't like it. So he made it thinner. He remade it himself. The air... excuse me. No, the ailerons were pretty... I don't know. It was a bit hard to make, to put the iron on and everything, and the cutouts. And then it's really long, which we like, because it offers nice lift in the tail. We called it the dragonfly because of the shape. Kind of looks like a dragonfly. Yeah. Hey! You'll find out. Yeah, that's pretty much it for that.
Alright, and for some of the challenges we faced, one of the largest challenges we faced was the motor system. Just because we didn't have like a pre-made one or anything like that we could work with, we had to all 3D print everything. So we had to print out I think a total of like 2 complete ones and like 3 fan blades. One of the first problems we had was this wasn't structurally sound. We didn't print it thick enough. So what ended up happening is when we got to higher RPMs, actually one of the blades here broke off. And then also as it would spin, it would kind of like expand and it would expand as it was spinning, and the blades would kind of flare out a little bit. So our first solution for that was 3D printing another ring to kind of glue on top of it. And it worked, but it wasn't as good as it could be. So on our second one, we decided to go like a little bit lighter and just wrap string around it, so that it was lighter weight, thinner, and just didn't really affect the height of it at all. And then the second problem we had was that this was actually rubbing quite a bit on it. So it ended up having balancing problems because like 3D printing isn't like exactly perfect. So it's almost like balancing a fan. It was kind of hit and miss. I took clay and I put it on a blade and tried it out and see if it was better or worse, and then kind of went around and ultimately ended up putting glue on the ones that needed more weight. So the one we have now in it is it's pretty balanced. And then for the other problem we had with it was that this was too close to here. It needed more like clearance. So what we had to do is we had to push it out more. So we had to actually retract this part more, so that the motor would push itself out. And then in that we actually ended up going too far. So we ended up printing a little spacer plate to get it just right. So it's pretty close to dead center in the new box we have. And then one of the other problems we were having, challenges we had, was the structural integrity, because we kind of have a heavy motor mount, so we couldn't really. We were originally going to do a 2-part design, but then decided that was too weak, so we ended up with what we have now, where we made it a little bit thicker. but we were still nervous about that, so we ended up putting like runners on it to beef it up a little bit. And then the balance was also a big part because the motor's like underneath the plane, and that's where like most of the weight is. You kind of want it more nose heavy, so we had to put all the electronics more towards the nose.
Yeah, we ended up mounting the wings to the body with just rubber bands so that all our eggs wouldn't be in one basket. So, you know, if something went wrong, we could always change something out. We also had a plan B, where if anything happened, we just punch out the centrifugal fan, shove in a piece of foam, and then strap a little propeller to the front. That's like the final plan, though, you know, just in case.
How we hopefully solve the problems that we already said. We stored a lot of the electronics in the nose of the plane to keep a lot of the weight in the front rather than the back. We 3D printed the fan because originally we were going to have the case of the fan made out of foam, but that was just too much of a hassle, so we 3D printed the entire case.
And there was no way we could mount like a solid motor mount to it without having it, you know, be kind of sketchy.
And the length of our plane was changed because we had to balance it, like Luke said, so we made it shorter. And the position of the wing weird because we wanted it to be strong right above the motor, the fan, but we also wanted it to be functional. That's it.